So yeah, so recall your 11th class, right? So in your 11th class, you guys understood about this fourth chapter, which was laws of motion, right? And in that you had the, or in the fifth chapter, I guess. So in the fifth chapter, you had work energy theorem, right? Work, energy, and power. So in that chapter, you learned that whenever you have, let's say, this object and you apply some force on it, right? So let's say this is the F force that you apply, and you displaces this object uh, at here. So this comes in here, and this is the displacement, right? So this object is moved from here to here, right? And then you calculate, so there is a work done on this object, and that work done is equal to Fs, right? This you did in your 11th class, right, guys?
Yes, sir.
Right. So this F can have, so this F can be of two types. One is that this F can be variable force. Oh, let me write first this F can be uniform, right? Or this F can be variable. Okay. So if my F is uniform, then work done would be how much? Then work done would be F dot S simply, right? And if my force is variable, then the work done would be integral of F dot dr, right? From 1 to 2, 1 to 2. Is that clear, guys?
Yes, sir.
Yeah, so let's say that I have a force which is 3I plus 2J plus 5K, right? So is this force a variable one or the uniform one? Which one is that? Yes. This is what kind of force? Variable one or the uniform one?
Uniform.
Uniform. So Aisha answer is uniform. Rabia, what is your answer? Yes, Rabia.
A uniform.
Uniform, right? Because for the variable one, we should have some variable. So does this force contain some variables? No, right? There's not any variable in this force. So this is not a variable force, right? This is a uniform. Good, guys. So correct. And let's say that if I write my force like this, 3x square I plus 2y z j, and let's say 3x square y square k. So now you see that this force contains variables, right? So this force is what? This force is what? Variable one, right?
Yes, sir.
Yeah, this is what you learned in your 11th portion. So the analogy is same, but the work is done by some charge, right? Work done is done by some charge. We are moving some charges in the presence of some electric field, right? So what would be that? So let's say that you have this force, right? So in that case, you had some mechanical force in here. Now that mechanical force will change to some Coulombic force, okay, or some external force. So let's say that you are in some electric field, right? You are some in electric field, And so in here you have some charge Q. So Rabia, recall our previous classes and you tell that what would be the force on this charge. Yeah. What would be the force on this charge? So that would be simply F would be simply QE. Right, force on charged particle in the presence of external electric field. This is the force, right? If I have a negative charge, so the force would be minus QE, right? This we learned in the earlier classes, right? Oh, my voice is lagging. Aisha, is my voice lagging?
No, sir.
Maybe your internet is not working properly, Rabia. Maybe your internet is not working properly. So this is the force, right? This is the electrostatic force or the electric. Oh, you rejoin. Yeah, you disconnect and then rejoin. So yeah, let us wait for Rabia, Aisha. Okay.
Yes, sir.
Yeah, where is she? Maybe she is facing some network issues. So let's wait for Aisha and then we can continue. Yes, can you hear me properly now, Rabia?
Yes, sir.
Good. So now you see that if I place some Q charge, right, in the presence of this electric field, so then I will experience some electrical force, right? Force due to this electric field. And this would be equal to QE, right? And now what I do is that I bring this charge
Yes,
from,
sir.
yeah, and I bring this charge from this point to, let's say, this point, right? Let's say this is 2 point, this is 1 point. So then this charge is here. Okay. So there would be some work done in bringing the charge from here to here, right? And this work is done right against this electric field. We are bringing this charge from here to here. So we are working against the electric field. So that would be how much? The external force that we need to apply would be F external, right? And this F external would be equal to the minus of force due to electric field, right? So this F external would be how much? This would be minus of QE. Okay, so is this part clear? I am bringing this charge from this 1 point to this 2 point. Is this part clear? Yes. Yes, guys, is this clear?
Yes, sir.
Okay, so the work done would be how much? Now my force is this. So work done in bringing a charge from 1 to 2 is 1, 2, and F external, right? Dot DL. Okay, so what is the value of this F external? This is 1 to 2 and minus of QE dot DL, right? So this is 1 to 2, and this would be equal to 1 to, which is this Q is constant, so I can take it outside, and this would be 1 into 2 E dot DL. So this is how the work done and the electric field is related. Okay, this is how this work done and electric field is related. So you guys note up to this point, and then we will talk about the next things. Okay, please note it down, and then we will go ahead. So whenever you guys need me to scroll down the screen, you guys please tell me.
So,
Yes.
for the NEET exam, will they ask derivations in physics?
No, no. So if I write directly the formula, right? Then if you don't understand that where it is coming from, then it would be right. So that is why I am just deriving these formula. Okay, just for the
No,
understanding.
so I meant like in general,
No,
will they
no,
ask these
no,
derivations?
no. There would be some MCQ questions. So they will ask directly the formula, or they will ask some numericals, right? They won't ask the derivation. Yeah, they won't ask the derivation.
Okay, so thank you.
Yeah, so where should I put the screen? In here.
Yes, sir.
Yes, sir.
You guys quickly note it down, and then we will, yeah, then we will do some questions. So whenever you guys have done noting, please tell. Done. Rabia, done.
Yes, sir.
Okay, so now you see, just for in the previous case, we had two kinds of force, right? The uniform one and the variable one. So in similar manner, We have two kinds of electric field. One is the uniform and the other one is the variable one. Okay, so for uniform electric field, this formula changes to simply this. 1, 2 is minus Q and E dot R2 minus R1. Okay, so we can simply write in a more understandable way is work done in bringing a charge from initial to final point is minus Q E dot RF minus RI. So this is the work done for the case of uniform electric field, right? And for the variable one, this is same. 1, 2 is minus Q, 1, 2 E dot DL. Right, so we need to only remember this one and this one. And now let us do some question based on these two concepts. Yeah, no, please note it down and then we will do some questions.
Done, sir.
Okay, so now let us do one question for the case of uniform electric field. So a charge one or let's say how much work is done in moving a charge 1 microcoulomb in the presence of electric field, which is let's say 3 into 10 to the power 3 I hat from P, which is 1, 2, 3 to Q, let's say 3 to 5. Right, so this is the initial point and this is the final point, right? So, and the electric field is, you guys tell me that electric field is uniform or this is volt per meter, right? So electric field is uniform or variable? Yeah,
Uniform.
uniform, right? So electric field is uniform, so we will use the first formula. This one, right? So we know that what is work done. So initial to final is minus Q E dot R final minus R initial. Right, this is the work done. So initial point is what? Initial point is P, final point is Q. So this would be Q E dot R final, which is RQ, minus R initial, which is RQ. Right. So Aisha, you tell me what is RQ? Yes. What is RQ? Position vector of Q point. Yes, Aisha. Am I audible? Yes, yes. So what is RQ? 3I, yeah, 2J plus 5K. And Rabia, what is RP? Yes, Rabia, what is RP?
That's I cap plus 2 j cap plus 3 k cap.
Good. So yeah, right. So we know RQ, we know RP, and we know electric field and the charge. Right. So we just this is microcoulomb, right? So we just plug in the value. So PQ would be how much? This would be minus of 1 into 10 to the power minus 6, right? And electric field is 3 into 10 to the power 3 I, and dot, right? So let us write this one. And RQ is 3I plus 2J plus 5K minus of I minus 2J minus 3K. So this one. So we'll have 1 into 10 to the power minus 6 into 3 into 10 to the power 3. And I dot, this is 3I minus I, so 2I. 2J minus 2J cancels, 5K minus 3K is 2K. Right, so I dot I will survive, I dot K is 0. So we will have minus 10 to the power minus 6 into 3 into 10 to the power 3 and 2. So this would be how much? 6 minus 6 into 10 to the power minus 3 joules, right? So this would be the answer. Any doubt in this, guys?
No, sir.
Yeah, so please note it down, and then I will give you guys one question, and you guys try that question. So whenever you guys have completed, please tell. Yes, done, guys.
Yes, sir.
Rabia, done.
Yes, sir.
Okay, so you guys try this question. So what is the work done in moving a charge, let's say 5 microcoulomb in presence of electric field, which is 10 to the power 5 and 3I plus 2J, right? From, let's say, P, which is 1 to Q, which is 3, 5. Okay. So you guys calculate and tell me the answer. Yeah, you guys quickly calculate and tell me the answer. Yeah, are you guys calculating?
Yes, sir.
Yeah. Yeah, whenever you guys find the answer, please tell. Yes, any answers yet? Yes, any answers?
1 minute.
1 joule.
Not that, it's 1 minute.
Oh, okay. Yes, Rabia.
No, sir, still calculating.
Yeah, please calculate and tell me the answer. Yes, any answers yet?
I'm not going to get final answer.
Yeah. Yes, what did you guys get?
I got positive 5.
You also got 5.
Yeah, but it was positive 5.
Positive 5. How? Let me see.
I think I missed the step.
Yeah, so yeah. And Rabia, what did you get? Yes, Rabia.
So I got 5.
You also got 5. Let me check my answer then, because you two guys are getting 5. So let me check my answer. So our final is 3i plus 5j, right? And this is I plus 2j. So RQ minus RP. So this is correct. 3i. So this is 3i, 2i, 5, 3. Oh, this is 5 minus 2. This is 3. Okay, so I don't. So this is 6. So this is 12 and this is 6. So minus 6. Okay. I'm getting minus 6. So yeah, the answer would be minus 6. So you see that there could be a calculation mistake also. So yeah, that is why practice is needed. Yes. So how did you guys get 5 also?
In the bracket, instead of RQ minus RP, I wrote RP minus RQ.
That could be. So just remember this formula. Initial and final. That would be good, right? Because then one can change this order. So then you would get minus plus, right? Opposite sign. So please just remember this formula. R final minus R initial. Then that would be enough. Yes, Rabia, understood.
Yes, sir.
Okay, now let us the other part is the work done in non-uniform field. Right, so we have a charge. We have a charge at this point, let's say O point, and this is 0, 0. And we bring this charge from O to P. So this P is 2, 0, and then we bring this charge from P to this point Q. So this is 2, 2 point, and then we bring this charge back to this point. So Q to O. So we are going first O to P, then P to Q, and Q to O. And what is the electric field? Charge is, let's say, a charge is a charge of, let's say, minus 10 microcoulomb, right? A charge of minus 10 microcoulomb is moved from O to P, then P to Q, and then back to Q to O, right? Back to O in the presence of electric field, which is x plus 2y I hat plus 2xj hat. Okay, and then we have to find work done in each path. Each path meaning from O to P, P to Q, and Q to O. And secondly, we have to find the total work done. Okay. So, did you guys understand the question? Yeah.
Let me explain once more.
Yeah. Could I what?
Let me explain once more.
Yeah. So I have a charge minus 10 microcoulomb, right? And it is kept at here. And what I do is that I move this charge from O to this point P, right? So I move in this way. I bring this charge from here to here. And then what I do is that I bring this charge from here to here, P to Q. And then again, I bring this charge from here to this, back to this initial point, O, right? In the presence of this electric field. So electric field is like this. And then I need to calculate what is the work done from O to P, work done from P to Q, work done from Q to O. So work done in each path. And then I need to calculate total work done. So this plus this plus this. Is that clear now?
Yes.
Yes.
Okay, so what kind of electric field is this?
No.
Variable.
Variable, right? Variable one, because we have X and Y variable. So we can't use that uniform formula. Then we need to use the work done, which would be 1 to 2, which is minus of 1, 2, and Q is outside E dot dl. This dl is the line element, right? So dl depends upon in which dimension we are moving. Okay, so let's say we are in one dimension. So this would be only this length, this short distance dx, right? And if I'm moving in this dimension, so this is only dy, right? This is dy. Okay, and if I'm moving in one dimension, so this would be simply dxi for 1d. And if I'm moving in two dimensions, so dx would be dxi plus dyj in 2d. Is this clear?
Yes.
Okay. Now let us calculate, and work done would be this. So now let us calculate what would be the work done from O to P. Work done from O to P. So this would be how much? Minus Q and O to P E dot dl. So what is the dimension that we have? How many dimension do we have? Yeah, this could be dy also, because if we are moving in y direction, so then this would be, yeah. So dl would be what? We are moving in which direction? Yes, guys, we are moving in which direction? Aisha, Maya, Rabia, any guesses? So this is only one dimension, right? And that dimension is x direction, only x direction. So your dl would be simply O to P and E dot dxi. Is that clear?
Yes, sir.
Okay, and we know how much is Q is 10 minus 10 microcoulomb, right? And E is 0 or O to P. E is x plus 2y I hat plus 2x j hat dot dx I hat. So only I will survive. So we will get what? This is plus 10 microcoulomb O to P and x plus 2y dot I. So only x plus 2y dx will survive because 2xj dot I would be 0. Right? Is that clear? Yes. Is this clear, guys?
Yes, sir.
Okay, so you guys tell me that what is the value of y in this line? Is y changing on this line?
No.
Y is not changing. And what is the value of y? Yeah, 0. So this part cancels out and we have 0. So the answer would be 10 and 0 to p and x dx. Is that clear, guys?
Yes, sir.
Okay, so we have this integral which is with respect to dx. So what would be the limit of this O and P? Only the x limit, because O is 0, 0, P is 2, 0. But we don't have a dy integral, only x integral. So this will change to 0 to 2 and x dx. So this will become x square. What is the integral of x? Yeah, integral of x. Aisha, what is the integral of x? Yes, Aisha, can you please recall what is the integral of x? Yeah. Rabia, integral of x. Did you guys forget integral? Yes. Yes,
So
guys.
is it 1 by x?
1 by x. Okay, I guess. Yeah, so you guys have forgotten integral. So you guys should have told me earlier because, yeah, Aisha, in my class, we did the derivation of potential due to point charge and multiple charges. So in that, we used integral. So you guys recall that what is the integral of xn? Integral of xn is xn plus 1 divided by n plus 1. So do you guys remember this? Yeah. Now do you guys remember this integral of xn?
Yes.
Yes, sir.
Yeah. So what is the power of x do we have in here? So 1. So this would be integral would be x1 plus 1 divided by how much?
2.
1 plus 1, right? So this would be x square by 2. So integral of x would be x square by 2 and we place the upper limit and lower limit. So upper limit is 2 and lower limit is 0. Right. So whenever we have upper and lower limit, so first we place the upper limit. So this would be 2 is constant, so we can take it outside. So when I place x 2 in place of x, so that would be what? Yeah, 2 in place of x. So that would give me what, Aisha? Yes, guys, Rabia. I have put x equals to 2. So that would give me just x equals to 2, which means 2 square, right? Because I have x square. And minus of the lower limit. Lower limit is 0. So this would be what? Yeah. If I have put x equals to 2, so this is 2 square. Now I am putting x equals to 0. So what would that be? Yes, guys. 0 square, right? So this cancels and we have 2 2s are 4. So 5 4s are, and one more thing, I had a microcoulomb. So this is 10 to the power minus 6. Right, so I have this 10 to the power minus 6 along with it. 10 to the power minus 6. So this is 4 and this is 5. So 20 into 10 to the power minus 6. Okay. Is that clear, guys?
Yes.
Yeah.
Okay. Now, so this is 20 into 10 to the power minus 6. So this would be how much? 2 into 10 to the power minus 5 joules. This is work done from O to P. You guys quickly note it down and then, yeah, you guys quickly note it down and then we will do the next part. Work done from P to Q. Yeah, whenever you guys need me to scroll down, you can tell me. So do you guys have any doubt up to this point?
No, sir.
Yeah, please note it down. Done. Okay. So yeah. So finished, guys. This is a microcoulomb.
Done, sir.
Done. So remember that this is multiplication. 10 into 10 to the power. Okay, done. So now let us calculate. Rabia, done.
Yes, sir.
Okay, so now we have a second path. Second path was that we are going from, so O, P, and Q. Right, this is 2, 2. This is 2, 0. Right, and I am going from P to Q. So Q is how much? This is minus 10 microcoulomb. My electric field is how much? This is x plus 2y I hat plus 2x j hat. Right. And what do I need? Yeah. So you guys, we need to calculate work done going from P to Q. So this would be minus of Q integral P to Q and E dot dA. So if I'm going from P to Q, what is changing? Which length is changing? Yeah, if I am moving upwards. Yes, Rabia. Y is changing. Yeah. So what would be DL then? DL would be what in P to Q? Will it be dx or dy? Dy. So dy, absolutely correct. Good guys. So dy j hat. So this would be minus q and p q e is how much? X plus 2y I hat plus 2x j hat and dot dy j hat. So only j and j will survive, right? So I will have minus q and p is what point? P is 2, 0 and this is 2, 2 q. And I will have 2x dy. Right, guys? Is that clear?
Yes, sir.
Okay, so now you guys tell me x is not changing, right? X is fixed. So what is the value of x at this point? From in moving from P to Q, what is the value of x? Yes. Rabia, what is the value of x? X is constant, it is not varying. In path P to Q, x is not varying, only y was varying. So Aisha said y is varying. So x is constant. So can you tell me what is the value of x? In moving from P to Q, what is the value of x? Rabia, any idea?
0.
Yeah, 0. So what is the value of x in here? Value of x in here at point P, value of x is? Yes. Yeah, Aisha, what is the value of x at point P?
2, sir.
2. Right, Rabia, did you get that?
Yeah.
So, and what is the value of x at point Q? 2 again, right? So it is fixed, it is constant. X is not moving. So this point is 2. So we can put it equal to 2 and 2 into 2 would be 4. So minus of 4q and integral of dy. So integral of dy is there. So we should take the limit of y. So y goes from 0 to 2. Right, and integral of dy would be what? y simply, right? So minus 4q is minus 10 into 10 to the power minus 6. And this is y, right? Y in the limit 2 to 0. So first we will put y equals to 2. So this would give us how much? Minus minus plus, so 4 into 10 to the power minus 5. And y equals to 2. So 2 and minus the lower limit, 0. So this is 2. So 4 into 2 is 8 into 10 to the power minus 5 joule. Is that clear, guys? So from path P to Q, my work done is this. Please quickly note it down, and then we will calculate the next part. Yeah, whenever you guys have finished noting, please. Yes, done. Rabia, done. Yeah, so any doubt up to this point? Yes. Any doubt up to this point?
No, sir.
Okay, so now let us do the last part. That we need to calculate the work done from. So OP we have calculated, PQ we have calculated. And now we have to calculate QO. Right. So we are moving in a QO path. Right, charge is here, and we are taking this charge from here to here. So Q is minus 10 microcoulomb. E is what? X plus 2y I hat plus 2x j hat. And DL. So now, can you guys tell me that we are changing in X direction, Y direction, or both the direction? In which direction we are moving? In X, Y, or both? Yes, Aisha. For the path QO, we are moving in X direction, Y direction, or both the directions? Oh, who got disconnected? Rabia got disconnected. So you see that we are changing Y also. So this is Y. Y is height. And this is the X. So height is changing, this direction is changing also. So this has some XY point, this has some different XY, this has some different XY. So we are moving in 2 dimensions, right, Aisha?
Yes, sir.
So DL would be what? Yes, DL would be in 2 dimension. What did we have? DXI. Will it be DXI only? Yes. So it will also have a DYJ. Yes, correct. So dxi plus dyj. So this is the length element that we have. So let's wait for Rabia for a few minutes and then we'll continue. Let's wait for her. Yes, network issues, Rabia, right? Okay, so we are now moving in QO part, right? In QO path, my X is also changing, my Y is also changing. So this is this length left is X and down is Y. So we are changing both the directions. So we are moving in 2D. So this length element will contain dx plus dy, right? So this is the length element. Now we know all the terms. So now let us calculate what would be QO. So this would be minus Q, and from Q to O we are going, and E dot dl. So this is minus Q and Q to O, and E is how much? X plus 2y and I hat plus 2xj hat. So this is E dot dxi plus dyj. So only I dot I will survive, j dot j will survive. So what will I get? Minus q and q to o x plus 2y dx. And plus 2x dy. Is this clear, guys?
Yes, sir.
Now you see that we are calculating the integral with respect to dx, right? But we have a function which is y. We can only calculate the integral whenever we have the function of x, right? We cannot integrate some 3y square plus 2y with respect to dx, because the integral is with respect to x, and we can't have a function which is y, right? So we need to replace this y with some x, right? Is that clear, guys?
Yes.
Okay, so now let me see how much do you guys know about the graph. So let me see how much do you guys remember. So let's say that I have this kind of graph. So let's say this is 3, right? This is x, this is y, and this is the graph. So this represents what? This line represent what kind of graph? So this is y equals to 3 graph, right? Because it is constant. So it is a constant graph, right? Y equals to 3 graph. And yeah, okay, rest. Yeah, so this is a constant graph, right? This is a constant. Y is not changing with respect to x. And if I draw this graph like this, okay. So let's say this is point 0, 0. This is point 1, 1. This is point 2, 2. So what is this graph? Yeah, what is this graph? Yes. So at 0 equals to, at 0, my y was 0. At 1, my y is 1. At 2, my y is 2. Right. So this graph represents that my y equals to x. Constant velocity, right? So y equals to x. This is the graph, right? Is that clear, guys? So y is equal to x is represented by this graph, right? So this is a straight line, and this slope, I would not say, I should not say slope, but yeah. So y equals to x line. Is that clear? If I
Yeah.
have, yeah, if I have 0, 0 and 1, 3. So this is 1, not 3, and this is 2 and 6. So can you guys tell me what is this graph? Yeah. What is this graph? So you see that at x equals to 0, my y is 0. At x equals to 1, my y is 3. At x equals to 2, my y is 6. So yeah, y is not equal to x, but y is right. Y is 3x. So this is uniform also. This is uniform, right? This is also uniform. Okay, because it is a straight line, right?
Yes.
So this is also a uniform motion. Whenever we have a straight line, that represents a uniform motion. When we have this kind of graph, so this represents non-uniform, right, Aisha?
Yes, sir.
Yeah, this is again a straight line. So, but dy would be 3x, right? Because if I put x equals to 0, y is 0. If I put x equals to 1, y is 3. If I put x equals to 2, y is 6. So this is represented by this equation, right? Yeah, so now for this equation, y is equals to x. Okay, so now we can come to this point that my y is what? My y is x. So I can write minus q and integral of q to o. And this is x. So x plus 2x integral dx. And this is in terms of y. So I can write q, o, and x is y. So 2y dy. Okay. So now the integral would be what? This is in terms of x. So x is going from what to what? X is from 2 to 0, right? X is from 2 to 0, and y is also 2 to 0. So x limit is 2 to 0, 3x dx, and y is also 2 to 0, 2y dy. So this is minus q. This is 3 is taken outside. This is x square by 2. Right. So this is from 0 to 2. And this is 2 outside, y square by 2, and 0 to 2. So this would give us how much? So first we have to put the value of upper limit. And 2 is constant, so it is taken outside. 3 by 2. First we have to take the upper limit, so 0 square. And then the lower limit, so 2 square. And then we have 2 is taken outside, 0 square minus 2 square. So this would be how much? This 2 cancel, minus q, 3 by 2 into minus 4. So, and this is how much? Minus of 4. So this would be how much? This cancels, and we have minus q, minus 6, minus 4, so minus 10. So this would be how much? Minus of 10 into, this is how much? 10 to the power minus 6, right? And then into 10 to the power minus 10. So minus minus cancels, and we have 10 into 10 to the power minus 5. Okay. Is that clear, guys?
Yes, sir.
So this is 10 into 10 to the power. This is from Q to O. You guys quickly note it down. So please note down from here. Any doubt up to this point? Yes. Any doubt up to this point, guys?
No, sir.
Okay. Yeah, you guys quickly note it down, and whenever you guys need me to scroll down the screen, please tell. Yeah. This is okay, right?
Yes, sir.
Yeah, finished up to this point.
Done, sir.
Yes, Aisha, done. Okay, so now we have calculated, so this was 0, 0. This was, let me write this as, this was O, this was P, this was Q. So going from O to P, work done was, I guess, 2 into 10 to the power minus 5 joule. Right. And going from P to Q, this was 8 into 10 to the power minus 5 joule. And going from Q to O, so Q to O, this is minus, this was minus, this was minus. What did I get? Yeah, so there is a minus. Okay, Q is minus, so minus, we will have a minus. So minus 10 into 10 to the power minus 5 joule. Right, you see that Q is minus 10 microcoulomb, right? Did I write it here? Yeah, minus 10 microcoulomb. So yeah, please correct this answer. So you see that what did I get? So in the total work done would be how much? Total work done in a closed path. This is a closed path OPQ. This is 2 into 10 to the power minus 5 joule plus 8 into 10 to the power minus 5 joule minus 10 into 10 to the power minus 5 joule. So this is 2, 8, 10 into 10 to the power 5 joule minus 10 into 10 to the power minus 5 joule. So cancels and we have 0. So if work done in closed path is 0, so what is the kind of the force that we have? Yes. For what kind of force the work done in closed path is 0? Yes, guys. Yes. Forgotten. So if work done in closed path is 0, so that force would be called conservative. Conservative force, and we can say that conservative electric field. Is that clear, guys?
Yes, sir.
Yeah, please note it down. So this was the last part, last question of this